Hi, I'm Arlette, and for my physics project, I explored something that happens literally all the time, boiling water. But I wasn't just boiling water to make pasta, I was looking at convection, how heat transfers through fluids like water or air. So I modeled a real-world convection scenario using a jar of cold water with food coloring placed into a pot of boiling water. Let's get into the science behind why the food coloring starts to swirl and acting like it has a mind of its own. Here's how I set up my experiment. I boiled the water in the pan on the stove and filled a glass jar with cold water and blue food coloring. I waited until the water in the pan was a roiling boil, then I carefully placed the cold jar into the pan and watched what happened. Immediately you can see the food coloring begin to swirl and rise. That's convection in action. As the hot water outside the jar heats the cooler water inside, the molecules start to move faster, become less dense, and rise, causing this beautiful motion. This entire process is driven by convection, which is one of the three modes of heat transfer: conduction, convection, and radiation. Convection happens when a fluid moves due to temperature differences, carrying heat with it. But to actually calculate what's happening, I use the heat transfer equation, Q equals mc delta T, where Q is the heat transferred in joules, m is the mass of the water in the jar, and C is the specific heat capacity of water, which we know to be 4,186 joules over kilograms times Celsius. Delta T is the change in temperature of the water in the jar. Let me show you how I use that equation. I measured 150 milliliters of cold water in the jar, converting that into 0.15 kilograms. My cold water started at 20 degrees Celsius and rose to 50 degrees by the end of the experiment. So plugging in our values, and after doing all the math, we see that the Q equals 18,000 over 18,837 joules. That means over the 10-minute period, about 18.8 kilojoules of heat were transferred to the jar through convection. To track how the temperature changed over time, I used a thermometer to measure the temperature inside the jar every 2 minutes. You can see the temperature increase here. The data matches our expectations. Temperature steadily increased as the hot water transferred heat to the cold jar. This shows the effectiveness of convection at moving thermal energy. Of course, for safety, I used oven mitts when handling boiling water, as well as wearing proper PPE. And so what you're seeing in this experiment isn't just some artsy food coloring swirl, it's a real-time demo of convection. One of the most common ways heat moves around in the world, and no, it's not just happening in a science class or in your kitchen when you're making ramen at 1 in the morning. Convection is basically nature's go-to move for moving heat. Think about it. Every time you feel the breeze on your face, that's convection at work. Warm air rising, cooler air rushing to take its place. That comfy blanket of warm air above a heater, also convection. Even the weather, like thunderstorms and ocean currents, run on convection like they're powered by the universe's own thermostat. Inside your own body, your blood acts like a mini convection system, moving warmth from your core out to your hands and feet. It's wild. So while my glass jar of swirling blue might seem simple, it's actually modeling how our planet regulates temperature, how our homes stay warm in the winter, and even how stars transfer heat in space. Convection isn't just a physics concept, it's everywhere. And once you kind of spot it, you can't really unsee it. But anyways, that's all. Thank you guys for watching. Bye!